right, let's talk about PA1. So so I graded PA1 over the weekend. I recorded grades. I posted comments with feedback, and some people came in this morning to talk about specific questions and so on. So PA1 looked good. A lot of people nailed this perfectly, had it all working. That was great. There were minor issues here and there sometimes, mostly around things like error checking and dealing with unexpected user input. And I would say probably if there was a single most common cause of point deductions, that would be it. Dealing with, if the person doesn't type in a number between 1 and 3 when you're asked them how many sticks to take. Things like that. But if there was a bigger issue, it was probably in the whole sort of gameplay flow itself, moving from turn to turn, having each person take a number of sticks and updating the state of the game and so on. So I want to go through an example of a working stick program, and this is just a version that I put together. It's not the best version, it's not the shortest version, but I think it's a fairly straightforward version. It's a kind of somewhat uninspired approach to the stick program. So I want to go through this as just kind of an example. And before we get into this, go ahead and send me an attendance note. Let me know if you are here.
Can I ask you a quick question about how to get out of the game?
Sure.
So, one thing that I was noticing online, because I was doing some Google searches on how to exit in Bash, and some of the people were saying that you can do break to break out of one loop, or break 2 to break out of a second loop. Is that something that you can actually do? Because I never got that to work.
So you can use break to get out of your current loop. I would avoid trying to break out of more than one loop though, because then it starts getting harder to read. But if you want to totally exit the program, you can always say exit, and just exit will get you out of your current script.
Okay. So
And
you think that's the most efficient way, the best way to just, if you're trying to end it, just do that?
that's one way. I mean, you could also break out of your loop and then have some code at the bottom of your loop that says, thanks for playing, goodbye, and then the script ends. That's not bad. There's lots of different pros and cons. I mean, sometimes it's useful to have a program that only exits from one place, such as the very bottom of the script. And some people will say, well, that makes your code easier to maintain. But sometimes, if something happens and it's really clear, I'm done, I want to exit, just having an exit right there, or a return if we're writing C, is a lot clearer than making the person reading your code say, oh, break, okay, so which loop are they going to break out of? Let me find the matching while statement, and then find where the end of that loop is, and now this is where they're going to go. So it really depends, and for something that you're writing for your own use and for me to grade, either of those would be equally good.
Okay. And then, like I was saying before, I noticed that someone had wrote a script and they used break 2 to break out of their nested loop and get back into their main program. Is that basically the syntax for that?
I've never tried a break 2.
Okay.
And like I say, I feel like that's
Actually works.
I feel like that starts getting into where there's probably a better way to do it. That's going to be easier for somebody to read.
Okay. Yeah, I could never get it to work, so I just didn't know if it was possible or somebody was just wrong.
Okay. So somebody just posted something in chat, and this harkens to something that I noticed in one case, and somebody asked in the previous section, which is, if you want to do an if statement, for example, we can do something like this. So if n is equal to 5, then echo 5, right? Now if I set n equal to 4 and I do that same if statement, it doesn't echo. But as somebody just mentioned in chat, it seems like in some cases you don't need this dollar sign, right? If I set n equal to 5 and I do this without a dollar sign, it actually notices that it's equal to 5. But don't do that. Always put the dollar sign in. The only time that you don't need a dollar sign on variables is when you're inside dollar sign paren. But it doesn't hurt to put them in there too, so put them in there also. And if you start getting in the habit of doing things like this, then you're going to get into a habit at some point where you say, you know, let's use n instead of dollar sign n, and you're going to like echo n instead of dollar sign n or something like that. So again, I'm trying to sort of force you to be very consistent, and this feels like a glaring inconsistency. So even if this looks like it works, don't do it. Stick to the dollar sign. Yeah, there was no prohibition on using functions. Some people asked about it, and I said that was fine. But I said earlier in the week that I was not going to talk about functions yet when it first came up. But then we did talk about them later on last week. And functions are you know, just say function haha curly bracket read n echo haha n. Right? So now anytime I say haha, it will wait for me to type a number, and then it will say haha on that number. Right? So you write functions kind of the same way that you do in C almost, right? You use the keyword function, the name, and then curly brackets and close the body. And that can be a nice way to bundle, you know, chunks of code that you call repeatedly or execute repeatedly. That's a way to put them into functions. But yeah, I have no prohibition against using functions, and it's actually a good thing to do. Let's see. So no, I don't generally have extra credit opportunities in this class, but you know, the programming assignments, we got 5 programming assignments, right? No one assignment is a make or break proposition. I think assignments are worth 30% of your grade, so each assignment is 6%. So if you get a 50 on the assignment, you've lost 3 points, right? It's not a huge deal in the grand reckoning. If you miss an ODP, if you miss a day of attendance, right, it's a pretty small point loss. Now, if you miss the midterm, that's a bigger deal. If you miss the final exam, that's a much bigger deal. But there's usually some kind of curving that will happen at the end. If, you know, at the end of the course it looks like the grades are kind of lower than what I was expecting, there may be some sort of curving that goes on. But particularly first assignment, I would say it's much more important, rather than worrying about the numeric grade, it's much more important to try to understand, you know, what you did and where you lost points and why you lost points for that, and what you can do going forward to avoid losing points in the future. And so that's you know, where you can come into office and we can go over specific issues and so on. And you know, I mean, if you knew how to program in Bash, you know, already, you wouldn't be taking this course. It would be, you know, just a silly hoop to jump through. So I'm expecting that there's some learning taking place, right? And so the goal is really, you know, as we go, to get better and better at programming in Bash and programming in C and using tools. So that's what we're working through. All right, so let's look at some sample stick code. So make sure you have a shebang in the top. That's important. And then I just kind of, you know, put a comment block here. Now, most people had a bigger comment block, which is important, right? I wanted a whole description, but this was just demo code, so I just said demo code and put my name in. But keep doing what you're doing. The commenting looked really good, by the way, in most cases. Lots of, you know, detailed description in the top of the assignment. You know, in some cases this went on for a page, so plenty of good stuff there. And also I saw lots of really good, consistent, meaningful indenting, so keep that up too. So, you know, print a welcome message, welcome to the matchstick game. How many sticks would you like to play with? 15 or more, and read a number. And then, you know, this is a while loop structure that you'll see over and over again. Don't worry about this part. This was checking to see if they typed in something like 15.2 or something, you know. But really all you need to do is while the number is less than 15, print a message, say, hey, it's got to be an integer, at least 15. Ask them again how many sticks and read the number. And so this kind of loop happens over and over again. Here I'm indenting by spaces, but no, nothing wrong with tabs. Tabs will usually indent to the next multiple of 8 spaces. So this loop, when we're done with this loop, what do I know? I know that num is the number of sticks to play with. And I'm actually going to use num throughout my script as the current number of sticks in the pile. So I print a response, let the person know what I just decided, which is we're playing with num sticks. And then I say who should go first, U for user, C for computer, and I read a variable called first. And then exactly the same while loop structure. While they have not answered correctly, which means they did not say U and they did not say C. And this has got to be an and. If I do an or, it's an infinite loop. So while they didn't say U and they didn't say C, print a message saying, hey, here's what you need to do. Ask them again who should go first, read their response. So just keep looping until they do that. All right, and then again, I'm just going to print out a confirmation. If first is equal to U, I'll say the user will go first. Otherwise, I'll say the computer will go first. So letting them know, you know, the consequences of what they just did. And then here's my 3-line instructions, right? Each turn, take 1, 2, or 3 sticks. Whoever takes the last stick wins. Good luck. And then I decided to show the pile of sticks. So here's a while loop from the ODP, right? Initialize a count, and then while it's less than the number of sticks in the pile, print a pipe. Increment the count. When you're done, print out your number inside parentheses. And then to actually get into the gameplay, I mentioned, you know, a few different ways last week that you could do it. So in here, I'm doing this by saying, you know, if the computer's going first, I'm going to do that outside my main loop. And then my main loop's going to be basically user followed by computer. So first thing I'm going to do here is check to see if the computer's going first. And I've got a little block of comments here explaining what I just said, which is the main loop handles the user's and computer's turns. But whichever we start with in the loop, if the other player is going first, we'll handle that before the loop. So since the user goes first in my main loop, if the computer wants to go first, we're going to do that before the main loop. So that's all of this stuff, right? And I chose the computer because the computer move is a little simpler. We don't have to deal with cleansing the user's input and so on. So if the first player is the computer, then I do a computer move. So take the number of sticks mod 4, put that in a variable called me. Me is how many sticks me, the computer, wants to take. And if me is equal to 0, change it to 1. And I'm thinking about, you know, the state of my system as I go through my code, as I write it and as I read it. So for example, at this point that I've highlighted, what do I know? Num is the total number of sticks in the game, and me is the number of sticks the computer just decided it wants to take. And I always want to know in my mind what are the state variables in my computer program. What do they represent at each point? Right now, num's the number of sticks, me's the number of sticks the computer's going to take. So if me's equal to 1, I'll say I take 1 stick, otherwise I say I take me sticks. That's just so it doesn't say, you know, 1 sticks. But you could say number of sticks I take colon and put out me or whatever. So I subtract me from the num, right, number of sticks. This is the new number of sticks. So again, at this point in my code, I'm still consistent. Num is still the number of sticks in the game. And I've seen a lot of confusion where people will have, you know, either variables called A, B, C, D, E, and it's really easy to get confused with those, or they have too many variables where you know, it's sticks 1, sticks 2, sticks remaining, sticks left, right? And you can get confused where what is the current number of sticks in my pile? Well, at this point in my game, it's sticks 1. At this other point, it's sticks left. At this other point, it's sticks, right? That's just kind of asking for confusion. So I've got one variable num. It's always the number of sticks left in the pile. So right here, that's what num is. So my while loop to print the pile is, exactly the same as before. I just iterate up to num. All right, now we're in our main loop, and this is a loop that runs consistently until, guess what, num, number of sticks in the pile, is not greater than 0. And this loop's going to do user code, computer code, user code, computer code. So users move, how many sticks do you want to take? 1, 2, 3. I read that. I'm putting that in a variable called u, and if it's not 1, not 2, not 3, then I'm going to say, hey, that's cheating. And I broke this into 3 lines just to illustrate, because somebody asked before, what if you had more conditions, right? So a backslash will continue a statement to the next line. And so, I can line these up. If I had 10 things I wanted to check for, I could check for all 10 of those just like this. Or I could just spread it out on one line like that. So if their answer was not 1, 2, or 3, I'll say that's cheating. How many sticks do you want to take? Read an answer. If it's not 1, 2, or 3, they've misanswered twice in a row, the game's over. Print a message, and then there's my exit to get out. And again, the indenting level here, right? All of this code is indented. That tells me I'm inside something. I'm inside my while loop. This is indented an extra measure because it's inside my if statement. And this is indented even further because it's inside an if statement, inside this if statement, inside my do loop, my while loop. Right, but then I quickly come back out of that and I can see, okay, so this stuff is going to happen just in my while loop, regardless of the value of my if statements. All right, so otherwise their answer was good. Subtract that from the number of sticks. Num is still the number of sticks in the pile. There's our favorite while loop to print out the picture of sticks, and then if num's equal to 0, I can say, hey, you won, and I can exit. Otherwise, it's the computer's move, so take the number of sticks mod 4. If that's equal to 0, set it equal to 1. Same thing we did in the beginning. And then tell the user how many sticks you're taking, subtract it from the pile of sticks, and then show the new pile of sticks, and then see if the pile of sticks is empty. And if it is, then you can say the computer won. And that's the end of our while loop, and that's the end of our whole script. And when I say this is very sort of inelegant code, I mean, I'm doing this loop that prints the number of sticks. I'm doing that like 3 different places in my program, maybe 4 different places, right? I'm checking to see if this is a legal move here, and I'm checking the same if statement here. I could put that in a function, right? That I just pass this number, and it tells me whether or not that's a legal number. I could do this check to see if somebody won the game in a function, right? So this is just, written directly out of my head, right? I'm thinking through what I want to do at each point, and I'm just writing down bash statements that do that part of what I want. So inelegant in that sense, but relatively straightforward to follow. And then if I wanted to tighten up this code, make it smaller, make it fancier, stretch my muscles a little or something like that, right? Then I can start writing some functions. I can start putting things into shared code and stuff like that. All right, let's see. More colors will be helpful in VI. Yeah, so by default, VI has color coding turned on, and as somebody said, you can do syntax on. I don't know if it's set up for me. Yeah, I don't have it on my version, but your version should support it, and it should come out by default, I believe. That's useful. Can you set it up to color code different blocks of code, your choice? I don't know if there's like commercial editors that do that by default, but you could definitely set that up. Almost absolutely, definitely in Emacs, I think, and possibly in VI. There could be ways to do that. Colon set number, that'll work on any version of VI. That'll give you line numbers, if you like line numbers. But that can interfere with copy and paste if you're going to use the mouse to copy and paste. If you want to know what line number you're on in your program, though you can always do a control G, and it'll show me I'm at line 139 or 154. And if you want to go to a line, like it said, syntax error at line 23, I can type a 23 in an uppercase G, and that'll take me to line 23. And we'll talk about VI later on this week, maybe, or next week. And there's a video I posted that gives you all of these tips and tricks. But there's lots of ways to go to specific lines or see what line you're on. Let's see, I did that setting. I do like it. I was thinking of extending the concept. Yeah, I haven't seen one that automatically lets you do blocks of code in a color. That does seem like it would be useful. And if it's not an option, you could probably add an extension to VI to do it. Let's see, make your variables as self-descriptive as possible. Since variable names virtually can be as long as one needs, one can say their number of sticks to be number of sticks, or the player being current turn state. So this is a excellent comment in chat. Go ahead and read that if you haven't already, right? When I first started learning programming, right, I was learning BASIC, and BASIC, your variable names are a letter or a letter followed by a number, right? And Fortran, your variable names, could have a few letters in them if you were lucky, right? If you were Fortran 4, it was a letter or a letter followed by a number, right? With Bash, C, Java, Python, any language you're using in the past, almost half a century or so, you can use variable names that are descriptive, right? So I called this first, but you could call this, who goes first, and it would be less likely that you would get confused when you're trying to test to see who goes first. You wouldn't accidentally use X when you had actually used N or something like that. So using good variable names is useful, and there's sort of two sort of main schools of thought. So if you want to record who goes first, so you can do something like who goes first equals, and put in your code for that. Right? So this is a valid variable name, right? And it's pretty easy to read. It says who goes first. That's actually something called snake case. But if you have a language that understands the difference between uppercase and lowercase, which most languages do, you could do something like this, where you capitalize the first letter of each word, but sometimes not the very first letter of the whole variable name. And there's another argument that who goes first, so that's another variable name. So camel case and snake case are two main ones. And yeah, there's probably religious wars on Stack Overflow about why one is better than the other, and so on. But yeah, pick good variable names. You've got the ability to use however many characters you want. Take advantage of that. And when I'm helping people with their code and we're trying to debug it in office hours and stuff, probably the most common issue that I find once somebody has code working but it's logically not correct is they're calling the number of sticks A and the number of sticks the user wants to take B, and the variable about who's going first is C, and stuff like that, and you get confused. You end up subtracting from C, and C is a letter telling you who's going first, not the number of sticks in the pile. And Bash in particular, there's no typing of variables, so if you have a variable equal to quote u and you subtract 3 from it, it will do that, and it'll leave you something bizarre. So yeah, go ahead and use good variable names. All right, let's see. So, as far as particular issues, couple of things that I saw hopping into a lot of people's code. So Git issues, right? So homework 2 was getting things set up in Git correctly, and almost everybody seems to have Git set up correctly right now. There's a few cases where you don't, and if you're not able to push to Git correctly, come to office hours. We got to nail that down. So if your code was in the wrong place, I noted that in the comments, but I did not make a deduction this time. I will in the future. If your file was not named lowercase stick exactly, I noted that, but I did not make a deduction this time. If your game did not, correctly ask for the number of sticks in the beginning and let the person keep entering them, that was a deduction. And in some cases, if you put in a bad number of sticks, it just played with, whatever number you typed in, or it exited, or it crashed with a syntax error, right? So those are things to check when you're running your code. So try putting in a bad number, try putting in gibberish, try putting in something smaller than 15, try putting in 14, right? Try putting in something really big and it should work. Who should go first? Try putting in nothing, try putting in some non-answers, and then try a U or a C, right? So I check those things. The picture of the pile of sticks needed to be, a set of pipes side by side, no spaces in between them, followed by no space, parentheses, the actual number, and then a closed parentheses. And that was something I was looking for in particular. So mainly because, I had 60 assignments and I ran each stick program, 5 or 10 times at a minimum. And then if it didn't work correctly, I ran it more times. So, I was playing, 400 or 500 stick games over the weekend. This jumps out visually, right? This is really easy to see as you're playing. I can see this pile, and I can really quickly look at this and I can identify, what the number of sticks was and so on, right? So that's a big visual cue. And if somebody was going to, run your output through an automated grading system, they would probably be scraping for that stick picture. So make sure the formatting is correct. Make sure you have a shebang in the top, that $! Exclamation mark /bin/bash. So I checked for that. Make sure that if the person puts in an invalid answer, which could be a number that's too big, could be a number that's too big, or it could be a number that's too small, or it could be a number that's negative, or it could be something that's not a number, and so on. Make sure that you let them know and you get another number from them, instead of just, making a guess or taking a 0 or something like that. Make sure you don't accept 0 sticks, because that's an easy way to cheat. And make sure that if they put in something illegal 2 times in a row, your game exits. So those all got checked. And then there were minor issues with, not using the right algorithm, picking a random number of sticks for the computer to take, or using an algorithm where sometimes the computer takes 0 sticks, things like that. So that's just checking different cases and making sure you're using the algorithm from the assignment. Syntax errors, definitely avoid syntax errors. Nothing in your program should cause it to, print a message from Bash saying, line 34 has a syntax error because of such and such a thing. And nothing should cause your program to give up and exit. Right, so those are usually big deals with assignments. And then commenting, like I said, commenting looked really good. Most people had a good block of comments in the beginning with all that information, and then lots of commenting throughout. Right, a few cases where there's 100 lines of program and there's no comments in it. You really need to be saying something, right? So I don't have a good level of commenting in here, right? I really should put a comment here saying, what's going on here? Let's make sure that the person typed a U or a C, and let's keep doing this, right? But I've got a comment down here, show pile of sticks. I've got a comment block here. But if I were grading this, I would say, try to put more comments in throughout your code. Okay. Um, but by and large, commenting looked good from people. Um, so if you have questions about the grading or about the feedback in Canvas and so on, definitely come by office hours. And I posted a couple of announcements in office hours. One is that I'm going to back away from Canvas emails because it's causing a lot of problems. So do, direct email to me at the address I listed like 3 or 4 times in that announcement. And please check your grades, right? Once they're entered, at least, every Monday, check your grades on Canvas for the past week. Attendance and ODPs, I upload those over the weekend. Assignments, I upload whenever I get them graded. But double check your grades. I'm still working out some of the logistics of dealing with 2 sections and a total of, the number of students we have and so on. So it's possible, I mess up and, you were here this day and you didn't get credit for it or something. So check your grades, and if there's a question, let me know. But you can't come in week 10 and say, hey, week 1 I was here 5 days and you only counted 4. So do it on Monday or Tuesday. I think I did an attendance ping in the beginning.
Yeah, you did.
Yeah, I did. I'll do one at the end. But if you didn't respond to the ping in the beginning, send me a ping. That's fine. All right. Any other questions, concerns about PA1? So let's see. Main question right now is, when would I use Bash over a C or precompiled program? Well, it's a good question. I don't have a repeatable answer for that. And I use Bash and C and Java. Those are pretty much my 3 languages these days. And I don't really have a clear algorithm in my head for when I use Bash versus C. I guess if I'm doing something that is going to interact with Linux at large, something that's going to execute commands, or want to pull out a date and timestamp using the date command, or create files or read files on the file system, I tend to go towards Bash if I think Bash can handle it. If I'm doing anything with more sophisticated parsing, sophisticated file management and stuff like that, I'll quickly jump over to C. But C is not as quick of a rapid prototyping thing as Bash for me. But that's only because, as I've been teaching Bash, I've gotten better at it, and now it's a tool that I'm pretty fluent with. But if you're going for speed, use C. If you're going for maintainability, I would say use C. If you're going for portability, I would probably use C. If you're going for anything that's pretty high on the computational things that it wants to do, sophistication-wise, I would go with C. But like almost all of my teaching tools are Bash. My script for setting up my cameras, for recording comments, for doing attendance scrapes, for all of that stuff. Those are all Bash scripts. Just because you can sometimes do in a few lines of Bash what might take you, hundreds of lines in C. All right, and one other comment was I had one person come in this morning who they had submitted their program. Their program worked great. Their GitLab repo looked great, but their program was not executable. I had to manually change the execute bit myself before I could test their program. And I left them a note, and they came into office, and we looked, and on their Unix system, the program was executable. But when they pushed it to Git, it did not end up being executable. It was listed as read, write only. And the only difference we could find is they were doing this from WSL. And when they went over to the Linux server and they did the same exercise, it pushed over and the permission bit was what it should be. So there may be something slightly off using WSL and Git and trying to push a bash script over. If you make it executable, that execute permission may not get set. And my theory, it's just a wild guess, is that maybe they push this over first, and then if the only change to the file is the permission bit, it doesn't notice that under WSL, and it thinks there's nothing I have to push. I don't know what the deal is, but anyway, if you're working from WSL and using Git, it's not bad to try cloning your repository into another directory and make sure that that executable bit is turned on when you pull it back down from GitLab. But that only happened in one case, and we already talked, so if you keep doing what you've been doing, you should be good. All right, so let's switch back to C, and we started talking about this a little bit last week, and I want to just keep going forward with this. All right, so we had this hello.c that we were working with, and we talked about compiling it. So compiling it with a -o switch to say call the executable program hello, and we stress the idea that whatever comes after -o is going to get modified. It's going to get deleted and written from scratch. So make sure this is the name of the program that you want to create, the executable program, and there's the source program. And now if I say hello, it runs my program. And I think the last thing we said on Friday was we were looking at this return statement, and if I say return 7, I can get a hold of that by looking at this bash variable called $?, and that will show me the value of what my program returned. And if I echo $? Again, it will show me the value of what my previous statement echo returned, which returned a 0. And the return value from a program is kind of up to whoever writes the program. There's some conventions, but there's nothing that really forces them. So I could say, you know, I want to return a 77. And now if I run my hello program and I look at $? It's a 77. And if I type a command that's not recognized and I look at $? I get a 127. If I try to do ls on a file that doesn't exist, $? Returns as a 2. Whereas if I do ls and it doesn't do anything abnormal, $? Is a 0. If I try to remove a file that doesn't exist, $? Is a 1. If I remove a file that does exist, it's a 0. So if you understand what the command's return values are, you can use those to know the result of executing this command. And most functions, you know, if you do a man on ls, if you get all the way down to the bottom, it will say exit status. 0 if okay, 1 if a minor problem, 2 if a serious problem. So that's a little vague, but you know, those are the things that it returns. All right, so we do our GCC command. So what is an executable file? It's stuff that the computer understands and we probably don't. All right. When you see this kind of stuff in your VI session, this is binary code. Right? We'll get an ODP in C tomorrow morning, so you'll get your fix. This is binary code. Caret @ is usually an ASCII character 0. And there's always a lot of zeros in binary files. And some of this is readable, you know, ld-linux-x86-64. Well, that looks like, you know, I'm using a Linux system, and it's an Intel processor x86, and it's 64-bit. But a lot of this is kind of unintelligible to us. And you know, this stuff in here is probably the machine code for my executable program. And if I were to, you know, change some of this, like let's, you know, get rid of a few characters and let's come over here and let's say haha, right? Well, I don't know what I just did, but it looks like I broke my executable program, right? I just, you know, modified the machine language of my program and, you know, did it in a way that it doesn't execute anymore. But if I recompile it, it'll go back to working. So you can use XXD to look at a file in hex, and this will show you, you know, a nice human readable output where, you know, beginning with the first byte of the file, we see the hex ASCII code for each character. And if that character is printable, we'll see it over here. So there's 16 bytes per line. And this is nice because, you know, anything that happens to be legible, it will translate for you. But if it's something that's not translatable, like 0, 1, or 0, 0, it just prints a dot. So this is nicer than going into VI, right? And sometimes this is a useful way to look at your code. There's also a nice command, strings. If you say strings and you give it a file, it will show you the strings that are human readable inside there, the sequences of consecutive characters. So that just pulls out, you know, the stuff that we can read as humans, including, you know, the thing that our program is printing, hello. But mostly we don't tinker with executables. We just run them. We just say hello or maybe /hello, and it executes. All right, so let's look at include files. So in the very beginning, we have this thing, number sign include. So if I get rid of that and I try to compile my program, I get a warning. Now, warnings don't stop your program from becoming executable. I can still run it, but warnings are important. You should never have warnings in your program. If you do, there's something wrong, and you should fix them, right? So always fix warnings. So what's warngings? What's the warning here, right? Implicit declaration of built-in function printf. So if you remember in C, and we'll talk more about this later, but when you write a function, you need to do what's called prototyping it, right? So if I make a function, integer my function, which takes a character argument that I'm going to call str, do stuff, return 12, right? And let's say up here I try to call this function, so I'm going to say my function, haha. And let me put my include back in. No, I didn't want that to work, but I knew it was going to end up working. Yeah, I think I have my warnings turned off. So if we're going to write C code and we're going to call a function, we normally have to put in the beginning what we call a function prototype, where I would say my fun is a function, it returns an integer, and it takes a character pointer. So this is a function prototype.
You can do that as number sign defined too, right?
You could do it with a number sign defined, but you'd still have to type this somewhere.
Yeah.
So yeah, so this is telling the yeah. So this is telling the compiler, right? It's not telling it what the code is inside my function. It's telling it what the arguments to this function are and what the return value is, what their types are. And then down here I actually write the function itself. Right? But the compiler wants to know ahead of time what types of things do these take. Well, we don't write the code for printf, right? I'm not going to make a function of myself called printf. So the prototype for that is inside this file stdio.h. Same thing if we do fgets, same thing if we do any of the things that we do in C where we use functions that we don't actually write ourselves. If you want to take the square root of something, you're not going to write a square root function, you're just going to say sqrt. But the compiler doesn't know what sqrt is unless you tell it. And so there's a file called math.h that, among other things, says, hey, square root is a function, it takes a double, it returns a double. So these function prototypes are available for us in this include file called standardIO.h. And so if you look under /usr/include, you'll see a bunch of files, including standardIO.h right there and math.h right here. And some of the other ones that you've seen, if you do malloc, you have a standard lib and so on and so forth. And these files are just C files that they don't contain runnable code, right? What they contain is declarations of what functions will look like. So for example, the printf function, right, is defined externally. It returns an integer. It takes a character array, and it takes a variable number of arguments. That's the prototype of the function. Now, if I type that myself, I wouldn't have to include standard I/O. But if I'm going to type this myself, I theoretically need to include, 994 lines of declarations. And you don't want to type all this in the beginning of your program, right? So you just say include standardIO.h. If you want to use a math function, you include math.h. And then when you try to use a square root, somewhere down here, oh, it's included somewhere else. But like pi, for example, is defined for us right here. So in the beginning of our C code, we usually have one or more include statements. If we're going to use string operators like string length or string compare, we include string.h. And they're really just taking the code that's in this file and basically plopping it in right here. All right. And the last thing I want to mention is send me an attendance ping. The last thing I want to mention is when you compile a program, right, if we just say gcc, -o file.c, this creates an executable called file. But there's actually a number of steps that take place towards creating that executable. So file.c is assembled into something called file.s. Well, sorry, it's compiled. It's converted from C code into assembly language, and then that .s file is assembled into a file.o, which is an object file. And then that goes through what's called a linker, or a loader, and that creates your executable file. And if we just say gcc, all of this stuff happens, and bingo, we've got an executable file coming out the other side. But in fact, if I say gcc-c file.c or hello.c, it will leave me the object file hello.o. And it's a lot smaller than the executable, and it looks, about as meaningful as the executable, but it's just the assembled version of my hello.c program without the extra stuff so that we can call printf and so on and so forth. It's not executable, right? It's really just a piece that's used by the linker to create the executable program. And if I say gcc-c-uppercase s hello.c, that does the assembly the compiling version down to assembly code, and it stops there. And if I look at that assembly code, that's my, in this case, x86 assembly language version of my program. And so one way to play with assembly language on this stuff is to compile your code, but do it with the -uppercase S switch. And that says, hey, compile my code into assembly language, but stop there and leave this .s file in place. All right, so tomorrow I want to start talking about feeding things into the program. I want to look at fgets, I want to look at scanf, and I want to look at argc, argv. And I'll post an ODP that will work with some of these concepts, and we'll just start playing with I/O and argument processing starting tomorrow. And that'll take us up to our next assignment, which we'll get into later this week. All right, thanks. Have a great one. I will see you next time.